Hello friends, welcome to Jonathan online class. In this particular video, I want us to solve this problem on the board, that is physics, and the topic is still elasticity. This is in continuation with our class last time. During the previous lesson here, we discussed the concept of elasticity, that the elastic properties of solid, where we stated the Hooke's law and explained the concept of stress, strain, Young modulus, and so on. Now, with the graph interpreted. Now, we want to look at a problem on elasticity. We're going to solve this example on the board. With this, you'll be able to tackle more problems on elasticity. Now, join me as we solve this together. Look at the question. The question says, an elastic spring of length 0.2 meter is stretched 3 times its length by a load of 40 newton. If the cross-sectional area of the spring is 0.5 meters squared, we are asked to calculate question I, the elastic constant, II, the stress, III, the strain, IV, the Young's modulus, V, the potential energy stored in the spring. Wow! These are array of questions. These are typical wire questions, and also a part of it you will see them in JAM as well. Now, quickly, in solving this question, we make interpretations and analysis. So look at this question. We are given that the original length of the material, let the original length be L1, 0.2 meter. Then we are told that the material is stretched 3 times its original length. So we are not given the extension, and the statement said it was stretched 3 times its original length. So our L2 will now be 3L1, which means 3 times 0.2, which will give us 0.6 meter. So this is our L2. Then, but if the question has said that it was stretched by, then you now know that our L2, our extension is given. If the question says it was stretched by, then you know that this will be our extension. But it says it's stretched 3 times of its original length. Okay, so our extension now, E will be L2 minus L1 will give us extension, which is 0.6 meters minus 0.2 meters. We now have the additional length, which is 0.4 meters. So this is our extension, our additional length. That's the final length when the load stretches the material minus the original length of the load of the material. We now get the extension, that's the additional length. Okay. From the question also, we are asked that the load that stretched it is 40 newton. Of course, you know the load is now force, 40 newton. So the load that stretched the material is the force in newton. Then we are told that the cross-sectional area of that material is 0.5 meters squared, and we have that A was to 0.5 meters squared. That's the cross-sectional area. Now let us solve our problems. Question I, the elastic constant. Then I question the elastic constant. Elastic constant is K. Recall from the Hooke's law, we have that F equals to what? KE. Therefore, our K will be equals to F over what? E. And what's our F? 40. Divided by our extension, 0.4. And that will give you 100 newton per meter. Because 40 divided by 0.4 is like saying 40 times 10 divided by 0.4 times 10. That is 400 over 4. That will give you 10. Okay, that will give you 100. That is 400. It's like saying 400 over 4. That will give you 100 what? Newton per meter. That's the unit. Force is in newton, extension is in meter. Then II. We are asked to find the stress, that's the tensile stress. Recall, last time we stated that the formula for stress is equals to force over cross-sectional area. And that is our force is what? 40. Our cross-sectional area is 0.5. So 40 over 0.5. It's like saying 40 divided by half. 40 over 1 over 2, which will give us what? 80. 80. So our stress is 80. Remember, stress has no unit. Okay, so it has unit, sorry. It is 80 Newton per meter square because force is in Newton and area is what? Meter square, Newton per meter square. That's our word, stress. Because 40 divided by half will give you what? 80. Okay, then we are asked to find the strain. For the strain, recall that the formula, like we stated last time, that the formula for strain is extension over original length. Not just over length, but over original length. Not over the final length. Our extension here is obtained to be 0.4. Our original length is 0.2. 0.2. Then 0.4 divided by 0.2 is like saying 4 divided by 2. I will have what? 2. So our extension is 2. Remember, extension has no unit because, strain has no unit because extension is in meter, length in meter. So meter cancel meter, you have this. Then we have IV. We are asked to find the Young modulus of elasticity. And recall, during our last class, we started the formula. The Young modulus, that's the symbol for Young modulus, is given by stress over strain. Stress over strain. And our stress is already obtained to the what? Our strain is obtained as what? 80. And our strain is 2. So 80 divided by 2 is 40. So our Young modulus has the unit of what? The number has the unit of stress, 40 Newton per meter square. It normally has the unit of stress, that Young modulus. Then V, the last but not the least, we are asked to find the potential energy stored in the spring. That is the elastic potential energy stored in the spring. Because the spring is the elastic material. It can also be referred to as work done in stretching that elastic material by the load. So we give it as what? The potential energy elastic, which is equals to work done, equals to 1 over 2 Fe, or equals to 1 over 2 Ke squared. So either of this formula will solve the problem. We are using one. Let us use this one. We have 1 over 2. Our force is already given as 40 times 40. Our extension is already there as 0.4 times 0.4, which will give you 2 divided 40, you have what? 20. 2 divided 40, you have 20. So 20 times 0.4, that will give us 20 times 0.4. And that will give us, it's like saying 2 times 4, which is 8. 8 joules. Because 20 times 0.4 is like saying, this decimal will cancel this 0. It's like saying 2 times 4, 8 joules. So look at how we solve this problem. So this is how to tackle problems involving elasticity, the elastic properties of material. Then, with this example, I believe you have now understood and will be able to tackle similar challenges or similar problems when it arises. Thank you so much for paying attention to this class. And for more of these solutions or tutorials in physics and mathematics, you now follow subscribe to my YouTube channel. You can also follow me on Facebook, on Instagram, and even TikTok. Then, if you have these special classes in preparation for JAMB, WAEC, NECO, NAPTEP, and GCE, you can reach out to me through my number here. You can chat me on WhatsApp. So I can hold classes for you on Zoom, via Skype or Telegram. Thank you so much for your attention. And